So this is the first example where we're going to do midpoint estimate of an area. So here it comes. Estimate the area under the graph of y equals 1 plus x squared. So this is similar to the previous problem, but what I want to do is I want to use the midpoint sum of 5 intervals. So let's see how this solution is different than everything before. Well, if the function is 1 plus x squared, so when x equals 1, we have 1 plus 1 squared, or we have 2. So the endpoint will be x equals 1 and y equals 2. The initial point will be x equals 0, y equals 1. And in between, we have this part of the parabola. Okay? Now, if you think about it, this area is made of a square, or 1 by 1 squared, right, plus the area of the parabola. So right off the bat, you know what is the value. We know that the area of the square is 1, and the area under the parabola, we just calculated it, and it was close to 1/3. And I told you that the exact value is 1/3. So the total area will be 1 and 1/3. Okay? Now, so what do we do? I said let's go ahead and divide it into 5 intervals, like so. So we have 0.2, 0.4, 0.6, 0.8, and then 1. But, wait, before we go, let's do it this way. Okay. So we slice it, let's show it to 5 with strips of, the width is 0.2, so delta x will be, delta x is always the last value minus the first value divided by the number of division, so it will be 1/5 or 0.2. Okay, now where is the midpoint? I need to change color here. The midpoint of the first interval will be the middle between 0 and 0.2, so it will be 0.1. And then the next one will be 0.3, the next one will be 0.5, 0.7, and 0.9. Okay, now to calculate, I tell you what, it will be easier to start with the last one. Where's the midpoint? The midpoint is right here. So we're going to create a rectangle at the intersection of the midpoint x value with the curve itself. And you can see that you have a portion on the left that is overestimate and a portion on the right that is underestimate. That's what makes this estimate very good and eliminate the need to take an average. And it's the same for the rest of the intervals. Again, overestimate on the left half, underestimate on the right half. This is true for increasing function. It will be the opposite for a decreasing function. Okay, for a decreasing function, the overestimate will be on the right side and the underestimate will be on the left side. So how this midpoint business works? Well, M sub 5 will be, we're going to write, it will be f of 0.1 plus f of 0.3 plus f of 0.5 plus f of 0.7 and finally f of 0.9 multiplied by delta x, which is 0.2. So if we actually calculate it, let's move delta x up front, so it will be, now we can leave it at the end, that doesn't matter. What is 0.1, f of 0.1? It's 1 plus 0.1 squared. Okay, the function is y plus equals 1 plus x squared. So it will be 1.01, right? F of 0.3, 1 plus 0.3 squared, it will be 1.09. 0.5 squared is 0.25, so it will be 1.25, and then 1.49, and finally 0.9. 1 plus 0.9 squared is 1.81. All of it is multiplied by 0.2. Add them up, and you get 210, 335, 484, 665. So it will be 665 times 0.2, or 65 divided by 5. So we have 1, and then 5 remainder of 1, 16. There should be 3, and then 15 will be precisely 1.33. Okay, there is exact. Now, this is a very, very good estimate, because if you consider the exact value will be 1 1/3, which is 4/3, which is 1.3 repeated. So we can write here, this is a very good estimate. Considering an exact value of 1 plus 1/3 equals 4/3 or 1.3 repeated. On this estimate, we saw today division by 5 and midpoint. We saw earlier today division by 4. We saw it also on Thursday. Is it a way to improve this estimate of the area? What can we do? I'm sorry? Take more intervals. Very good. Take more intervals. Really, this is the key to integration. So a better evaluation of the area is obtained by increasing the number of divisions. So let's write here a note here. So a better evaluation of the area is obtained by increasing the number of divisions. But what happened when we increase the number of division, the number of intervals? So let's write in parentheses the number of intervals. This is the same as what? I'm sorry? What happened to delta x? This is the same as decreasing the value of delta x. I agree. Yeah. So that's what we're going to do next. We're going to see what happens if we increase the value of intervals or decrease the value of delta x.